Okay, welcome to the Unit 4 Lesson 5 on solving polynomials by factoring. So our learning targets for today would be solving polynomial functions in the quadratic form, so not necessarily quadratic functions, but in quadratic form, which we'll talk about when we get there. Solving polynomial functions by grouping, and solving perfect cube polynomials. So let's begin by talking about the first step that you should always be looking for when you're factoring is looking for the greatest common factor, the GCF. Right? So in this example, I see 2x to the fourth, negative 10x to the third, and positive 12x squared. So each term shares a 2x squared. So when I factor that out, that leaves me with an x squared. And that leaves me with a negative 5x, and then a positive 6. And so that factors out the GCF of 2x squared, and the resulting quadratic can now also be factored. And for the sake of simplicity, I'm going to assume that you know how to factor this. So factors of 6 add up to negative 5. Would be x minus 2 and x minus 3. If you have trouble with that, then come see us and we'll talk about factoring in more depth. But again, we're looking for solutions, so we're looking for what makes this equal 0. So I have 1, 2, 3 factors. Each one should be set equal to 0 and solved. And that is the zero product property. So 2 times x squared, divide by 2, take the square root, and you get x equals 0. Add 2 to both sides, you get x equals 2. And add 3 to both sides, you get x equals 3. So my roots, my solutions, my zeros are 0, 2, and 3. So that is solved by factoring out the GCF. So go ahead and pause the video and attempt problem number 1. Alright, pause the video. Okay, and here are the solutions to problem number 1. You should have 0, 4, and negative 3. So if these are not the solutions you came up with, check back over the work, see where you made your mistake, and if you can't find it, talk with us and we'll see if we can find out what you did wrong. So the next thing here is quadratic form. So it's when it's not necessarily a second degree function, it's a fourth degree function, but it follows this pattern where there's a constant at the end and then the leading degree is twice the size of the middle term. Right? So 4, 2, 0, another pattern would be 6, 3, 0, or 8, 4, 0, if we're talking about x's. Right? X to the 8th, x to the 4th, x to the 0. That's in quadratic form. So hopefully you kind of see that pattern. We're really only going to be focused on quartics that are in quadratic form. Again, look for a GCF. 2, 1, 6. There isn't one. So we're going to factor this like you would any other quadratic, and you can use the box method, also known as the area model, or you can use grouping, which you'll see in the next part. So 2x to the fourth, and then negative 6. So I'm looking for factors of negative 12. That subtract to give me negative 1. So negative 4, positive 3. So negative 4x squared and positive 3x squared. So I can factor out a 2x squared here. That leaves me with an x squared and a negative 2. Take an x squared out of here, it leaves me with a 3. So our factors are 2x squared plus 3 multiplied by x squared minus 2. Set that equal to 0, and then we'll solve by setting each factor equal to 0. So 2x squared plus 3 equals 0. X squared minus 2 equals 0. So I end up with x squared equals negative 3 over 2. So I take the square root of that, right? That's going to be imaginary. So this gets a little complicated here, trying to take the square root of a fraction. Will be fine if you just say, let me kind of go back here a little bit, plus minus I square root of 3/2. All right, we want to see the I, we want to see the plus minus. We're not going to be so concerned with this simplifying this radical in this unit. When we get to the rational exponents unit, we'll work on that more. All right, so let's solve this. We get x squared equals 2, square root both sides, and we get x equals plus minus the square root of 2. So in this case, this fourth degree polynomial had 2 imaginary solutions and 2 real solutions to give me a total of 4 solutions. All right, so go ahead and try this next example. Or sorry, this is an example, so I'll work it out. 2x to the 5th, negative 16x to the 3rd, and 32x. That's a GCF of 2x. So x4 minus 8x squared plus 16. So factors of 16, that's to add to give me 8. That's going to be, let's see, x to the 4th, negative 4x squared, negative 4x squared, and 16. So x squared minus 4, x squared minus 4. So in factored form, it would look like this. So now they're the same thing, so I'm only going to do it once. X squared minus 4 equals 0. So x squared equals 4. So x equals plus minus 2. Now since that had a multiplicity of 2, each of these have a multiplicity of 2. So positive 2 with a multiplicity of 2, negative 2 with a multiplicity of 2. So that gives me a grand total of 4. I also have this 2x that I forgot about. So that also needs to be set equal to 0. And I get x equals 0. So you have 0 with a multiplicity of 1. And there's all my zeros with their multiplicities. 1, 2, 3, 4, 5. That matches. So 5 real, 3 distinct, and 0 imaginary. All right. So go ahead and pause the video and try to factor number 2 by using quadratic form. Remember to factor completely and remember to solve at the end to get the zeros. So pause the video and attempt number 2. Okay, so you should have gotten the solutions positive and negative 3, positive and negative 2i. So again, this is a 1, 2, 3, 4 solutions to a fourth degree polynomial. So I have 2 real, 2 imaginary, to make a grand total of 4. All right, if you had any trouble with that, look back. Now, you notice x squared minus 9, I could factor it into x minus 3 and x plus 3, and then you solve each of those, you still get a positive 3 and a negative 3, as if you didn't do this. So if we're asking you to solve, you can jump from here to here and solve, as long as you give us plus minus. If we're asking you to factor completely, make sure you factor that x squared minus 9 as well. All right. So factor by grouping. So when we give you 4 terms, we're going to do factor by grouping. So we're going to kind of group the first 2 and the last 2 and look for GCFs. So I see a GCF of 4x squared. That leaves me with an x minus 5. I see a GCF of negative 5, which leaves me with x minus 5. Now, these two are common, so x minus 5, and that leaves me with 4x squared minus 5. Set it equal to 0, and solve from there. X minus 5 equals 0. 4x squared minus 5 equals 0. X equals 5. X squared equals 5 over 4. So x equals plus minus square root of 5 over 2. So hopefully you've done enough work with radicals to know how 5 over 4 becomes square root of 5 over 2. If not, we'll probably be able to accept this for this unit until we get to, again, the radical unit. But this would be the simplified version. Alright, so go ahead and pause the video and attempt to factor by grouping for number 3, and then come back and check out the answer. Okay, so here are your solutions for number 3. I have 4/3 and plus minus I root 3. So again, in this case, we have 1 real and 2 imaginaries for a grand total of 3 solutions. Alright, so now we're going to get into something that should be relatively new to everybody, which is factoring perfect cube polynomials. Okay, so we're going to kind of break this down and simplify it into a couple of different scenarios. So if I call this, say, a to the third plus b to the third, and I was to factor this, I would get a plus b as my first factor. Then I would take this and I get a squared minus ab plus b squared. Whereas if it was a to the third power minus b to the third power, in that case, I would get a minus b, a squared plus ab plus b squared. So these are 2 different forms of factoring perfect cube polynomials, your 2 possible possibilities. Alright, so a couple mnemonic devices to help you remember how I got this would be SMS, which stands for square, multiply, square. Right, so took the cube root of both, and then I squared the first term, a squared. I multiplied a times b and got ab, and then I squared the last term to get b squared. Same thing over here, a times a times b, and b times b. So now, in terms of the signs, we can use another acronym, or sorry, mnemonic, would be SOAP. So same, opposite, always positive. And this is for the signs. This tells you what your sign should be. So if this is plus b cubed, it's plus, so it's the same, it's the opposite, it's always positive. For the negative, it's the same, it's the opposite, it's always positive. Alright, so the square multiplies square, that's for the numbers. Alright, so let's take a look at this for an actual solution, an actual problem. So the cube root of 8 is 2, cube root of x cubed is x, so it'll be plus 3. And now 2x times 2x is 4x squared. 2x times 3 is 6x, but it should be the opposite. And then 3 times 3 gives me positive 9. Okay, so that's factored. Now I'm going to set this equal to 0, and then I'm going to solve. Now the nice thing about this is that the first one is going to just be a regular real solution, so x equals -3/2. The second one is always going to be imaginary. So if we're asking you for real solutions, that's going to be our answer. If we're asking you for all solutions, then you're going to have to do the quadratic formula for this. So x equals the opposite of b plus minus the square root of b squared minus 4 times a times c. And that's a 4 all over 2a. So if we were to multiply this, this would be 16 times 9, which is 144. So 6x plus minus, and 36 minus 144 would be negative 108 all over 8. Square root of 108, I believe that should be 3 36s. So that gives us 6 plus minus 6i root 3 all over 8, which we can then simplify to 3 plus minus 3i root 3 all over 4. And there is a pattern to all of this that if you do enough of these, you should be able to see. But for now, we just want you to be able to find the real solutions and find the imaginary. And then once you do a few, see if you can figure out the pattern so you don't actually have to do the quadratic formula to write this out. Until then, use the quadratic formula. Alright, so I'll do one more example here. The only difference for this example is that there's a GCF first. So I'll take that 4x out. Leaves me with x to the third minus 8. So I'll factor this, keep my 4x, and I'll get x minus 2 multiplied by x squared plus 2x plus 4 equals 0. So 4x equals 0, x minus 2 equals 0, x squared plus 2x plus 4 equals 0. So x equals 0, x equals 2, and here's all your solutions. So 0, 2, and negative 1 plus minus I root 3. So if you did the quadratic formula, this should be what you end up with. And so I kind of use the pattern. So maybe that can help you to figure out what the pattern should be. So let's go ahead and try number 4. Alright, try number 4. Pause the video, give it a try. And again, here's our solutions. You have one real and you have two imaginary. Again, if you do the quadratic formula, this should be what you get from the quadratic formula. And once you simplify it, this is what you get down here in simplified version. Again, there's a connection between these, and once you start to see the pattern, you can start to kind of jump between your real solution and your imaginary solution. So try to figure that out, and we'll talk about it in class, and see you next time.